All right, we're back. We are on page 11 of notes 23 of Calc AB. We're talking about slope fields, and we've done a ton. We did some matching stuff. So this page actually is basically a summary, and then it explains a little bit about how you can use some technology things to create your own slope fields, which is a fantastic way to learn things about slope fields. Let's look at some of the things that are in this little summary here. So when you are looking at a slope field, you are looking at all the possible solution curves. You are not looking at a graph of the differential equation. You're looking at the possible solutions to the differential equation. The solution to a differential equation, this hasn't come up too much except when we were graphing the particular solutions on page 10 for the hyperbola in particular. The solution must be a function. So it must be a function. It must be a continuous function on an interval that contains the initial condition. That'll be more important in the next set of notes when we are actually solving differential equations. There's a lot of things that you can look for. I hope that you already know those. To draw a slope field, you want to find the slope at each individual point that you're asked about, and then just draw a little tiny tangent segment. And that's really all they are. They're just like a giant collection of tangent segments. So there are two things that we can do technologically. So the first one is on your Nspire. So I'm going to switch over to an Nspire screen and just show you really quickly, or maybe not so quickly. I don't really do anything quickly. I'm going to start a new document here. You might recognize from way earlier in the year. And it's the last page of some set of notes, maybe notes, I don't know, notes 8 or something like that. So new document, I'm going to add a graph page. And so what I want to do is change it so I can actually graph a differential equation, or graph a slope field, right? And so what we do is we're going to pick differential equation. So it's menu 3, option 8, and then it changes and it looks like this. What is happening here? All right, so I'm just going to type in X and hit enter and see what happens. So it does an okay job. It doesn't look great. If you go back up, so I press tab and then I arrow up. And if you go over to the 3 dots, which I think you can hit tab and enter, it will open this up. You don't want to mess around with this or this or this or that or that. What you do want to mess around with is field resolution. I always turn it to 30 and then just press enter. And now it looks a lot better. Okay, so this will give you a better looking slope field. Another thing you can do is press tab. You can put in an initial condition and it'll try to sketch a solution curve. So I'm going to put in 1, 1 and press enter. And you can see that it tries. It's plotting points, so it's using something called Euler's method to find these points and then plot them. If you're in Calc BC, you either have talked about that already or you will talk about it soon. If you're in AB, you don't have to know it. It has to do with tangent lines. It's very cool, but that's for the future. So it'll do this. Now, one of the things that we have said is that you can't, if you hit a vertical tangent line, a vertical asymptote or a horizontal asymptote, you stop. When the slope is undefined, you stop. I'm going to try to illustrate that for you and illustrate another thing. So when you put in your differential equation, if you're in y1, you have to use y1 as your variable. So I'm going to press enter and just see what happens. So here we go. We get our slope field. I don't actually know if this is going to do it. Well, let's see. I'm going to put in 1, 1 again. So 1, 1, oh, is y equals x? Y equals x, yeah, let's put in 1, 0.5. So it's not on y equals x. And press enter. Oh, and it does a good job. Okay, so that's not what I wanted. I want a bad job. So I'm going to put negative. There you go. Okay, so what is happening here? Well, what's happening is the calculator is starting at 1, 0.5. And then it's kind of just moving along a tangent line a little bit. So you can actually trace these. I'm going to do menu 5, press enter. So you can see it's like here, then here. Now, when I press enter again, it goes crazy. And it's just like messing up. And so this is a really clear, I think, example of why like your solution needs to be continuous on an interval that contains your initial condition. The calculator doesn't really respect that when it tries to draw a solution. So be on the lookout for that. If you find this scenario, it means that the calculator is doing its best. Its best just is far from enough in this case. So Another thing that we can do really quickly, I keep saying that about everything. So I'm gonna just turn it back into, let's do x times, I don't know, y1 minus 1. X times y1 minus 1. Okay. All right, so that kind of looks like that. I don't know. Oh no, let's make it, let's do one that we kind of recognize. Let's do x plus 2y minus 1. Where's my slope field? Gone. Let me, oh, you know what it is? We all see y. I just used y, I didn't use y1. There you go. It's important that you use y1. So this is a pretty good slope field. What I want to do, so it's y prime is x plus 2y minus 1. I'm going to add a calculator page. And I'm going to press menu and option 4 for calculus. I'm going to press up, up, up. So to get to part D for differential equation solver. So I have a CX2, which makes this pop up. If you have a CX1, you'll see at the end what you need to type in. So x, I don't remember what it was. Oh no, I think it was like x plus 2y minus 1, potentially. Independent variable is x, dependent variable is y. Condition, y of 1 equals 0.5. And then I'm gonna press enter. If you have a non-CX2, this is what you type in. Just type in, well, this, I don't even think this should work. Well, maybe it will, let's see. Yeah, okay, so that didn't work. The reason it didn't work is because I'm supposed to type in y prime is equal to, y prime equals. So where do you get prime? In the question mark? I don't know. I mean, it's actually an apostrophe is y. Question mark, and then just press it a bunch of times, you'll eventually get to prime. So y prime equals, now let's do it. Okay, so whatever. So it's x plus 2y minus 1. So it's really important that I get that right. I'm not sure I did. I'm going to store this function as f1. So I'm storing the function. And I'm going to go back over here. And let me just make sure it was x plus 2y minus 1. So I think that's right. Press tab. Rather, press menu. Go to option 3, change it back to function. And since I stored it, I'm going to press enter. This is the actual solution. So if you've never used differential equation solver, it's awesome. You should definitely learn how to use it. I have another video on how to use it. You should probably watch that for more information. But I've used it, I stored it, and now we're graphing a slope field and a particular solution. That's a pretty cool thing to do. So these are all the calculator things you can do. The other thing I'm going to share Chrome. We're going Chrome here. Okay, so this is my website. It's turksmathstuff.com. Click on get to Calc AB somehow, and then scroll down until you get to notes 23. When you get to notes 23, it says here's a link to an online version of a GeoGebra thing. Now we're going to GeoGebra. So this is actually, I think, a little more useful. This will open. Basically, you can ignore everything in here, like everything, except for this part right here. And this part, just change it. And when you change it, you can watch the effect kind of like ripple through. So we get this. And I think that playing around with this, you can learn like a lot about differential equations, what they look like. This is where I got all the graphs that I used in the notes. So I wanted you to be aware of that. Also, you can play around with it. And that's it. So I'm going to go back to the notes, I think, unless I accidentally end the video, which I sometimes do. And then call it a wrap on slope fields. Be back in the next set of notes. We're going to talk about solving differential equations, which is a big deal. This just explains basically the GeoGebra file. You don't really need to understand it to be able to use it, but dig into it if you really want to know how I made it. I would encourage you to do that. And we use the Nspire. And the more technology you can use, the better, because it just helps you to understand better. But anyway, I hope you have found these helpful, and good luck.